In the second part of the control flow tutorial, we will be discussing the second conditional statement, switch. Switch is similar to the multiple if statements we have already discussed. In the case of switch, we have a switch parameter, and we have a list of cases to which a value is attached. So using the switch statement, the value of each case is compared to the value of the switch parameter. If those match, a body of code which is associated with that particular case is executed and the other cases are ignored. In Swift, it is possible for a number of cases to have values which are equal to the value of the switch parameter. And if something like that happens, the very first case on the list whose value is equal to the value of the switch parameter will be selected, and the body of code associated with that case will be executed, and the other cases will be ignored. In Swift, an important thing about switch statements is that the list of cases must be exhaustive, which means that the list of cases have to cover all the possible values of the switch statement. To help us to make sure that that is the case, it is possible to use a default case to cover all the cases which have not been covered by the individual cases on the list. Here is the syntax of a switch statement. We have the keyword switch and also the keywords case and default. Notice that after all the cases and default, we use a colon that is necessary. And notice that the switch statement has an opening and closing curly brackets within which the list of cases and the possible default case are included. The switch parameter is inserted between the opening curly bracket and the keyword switch. The values associated with each case appear in front of the keyword case and before the colon, and the body of code associated with each case appears beneath each case. There is no need for curly brackets for the body of a case. One important thing to bear in mind is that in Swift we are not allowed to have a case which has no code within its body. So for each case we should have a code to ensure that we don't see an error. In Swift we could also have something called a compound case. A compound case is associated with multiple values, and the syntax to show a compound case is shown here. For the case where we only have two values, we could have more than two values. So we start with the keyword case, followed by the case values separated by the comma, and the very last value is followed by a colon. When we see a case like this, it means that if the value of our switch parameter is equal to any of these case values, the body of the code which appears below this case will be executed. As I mentioned before, multiple cases can have values matching the switch parameter, and in such a case the very first case is executed and the rest are ignored. Here's a simple switch example. Our switch parameter is x, which in this example is declared above. We have 3 cases on our list plus a default case to make sure all the possible values of our switch parameter x are covered. So if in the case where the value of x is equal to 0, this is the line of code we run. If the value of x is 1 or 2, this is the compound case. This line of code will be run. If the value of x is equal to 4, this is the body of code which is run. And if none of these have values equaling the value of x, we run the default case, which would be the running of this single line of code. Switches can be used together with value ranges. So instead of having individual values for each case, we can have a range of values. In this example, we are using 2 ranges. For case 2, we're using range of values from 1 to 19. And for the case 3, we're having range of values from 20 to 50. For case 1, we have a single value, there's no range, and also we have a default value. So in the case of value ranges that we have here, for this case, for instance, we are saying that if the value of our switch parameter x falls in the range between 1 to 19, this is the code that we have to run. In the second value range that we have here, if the value of x is anything between 20 to 50, this would be the body of code that we will run. We can also use tuples in conjunction with switches. Tuples will be used as both switch parameter and the values of the cases. It is important to note that whatever the types of the tuple that we are using are, the values of the cases should have the same types. So for this particular example, where our switch parameter is x, which is a tuple of type character and integer, the tuples used for each case are also of type character and integer. So in this example, what we are saying is, if the value of x, which is a tuple, has an element, first element, which is equal to character b, and the second element, which is equal to 2, this is the code that we run. The second case says that we don't care what the first element of x is, but as long as the second element is equal to 3, this is the code that we run. In the third case, we don't care about the second element of x. So we are saying that as long as the first element of x is character C, we run this line of code. The fourth case here is saying that as long as the first element of x is C and its second element falls in the range 4 to 9, this is the code that we run. Otherwise, we run the code within the body of the default case. With switches, an idea called value binding can be used. Value binding is a method whereby when a switch case is matched, one or more temporary parameters are created. Then the elements of the switch parameter will be assigned to these temporary parameters, and these parameters are used within the body of the matching case. The idea of value binding using switches is shown here. So we start with our switch parameter, which is declared above. Notice that in this case we're using tuples for our switch parameter. Then we have a number of cases defined here, and in the first case we are saying that if the second element of x is equal to 2, regardless of what the first element is, we define a constant called a and set it to the first element of x, and then we use that value, that constant, within the body for this case. And at the end, when we are finished with everything, we delete a. The reason for deletion here is because a is meant to be a temporary constant. It's only available within the body of this case. The second case indicates that if the first element of our switch parameter is equal to b, regardless of whatever the second element is, we define a temporary variable and call it b and set it equal to the second element of our switch parameter. We use that variable within the body of this case and delete it at the end because it is temporary. The last case shows the situation where we don't care what the elements of x are. We just define two temporary constants, a and b this time, and then we use it within the body of this case, and at the end we delete them. Because of the usage of underline here, this is effectively the same case as a default case. So we don't have a separate default case defined for this example. This is a relatively long-winded version of value binding. In Swift, a shorthand is used to achieve the same thing. That shorthand is shown here. So switch x remains as it is, but a declaration of a and assigning the value of x dot node, which is the first element of x, to a is shown by moving let a within the tuples parentheses and placing it in the position corresponding to the element of x that we want to use in the assignment process. So in this case, we want to assign the first element of x to A. So we put let A in the position of the first element of our tuple. And the rest of the code will remain as is, but notice that A, which is declared in here and a value is also assigned to it, can be used within the body of this case. We don't need to mention, we don't need to do any deletion here, and this automatically shows that A is a local parameter and it's only valid within the body of first case. In the second case, what we do is we move this var b and put it in the second position. Again, the second position is used because this thing is assigning the second element of the switch parameter x to b. So we put var b in the second in the position of the second element of our tuple, and the rest of the code remains there. And lastly, we move both let A and let B in these two positions. Instead of the underscores, we just use directly let A and let B, and for the same reasons that as we mentioned before, the positions of let A and let B are selected according to the assignment that we want to use. Instead of using two lets within the parentheses, we can just move out the words let and use only one of them outside the parentheses. This is similar to factorizing in mathematics. So this is effectively saying that both A and B are constants. That's why we're using let. So let is going to be applied to both A and B. Value binding is also possible with a condition introduced by a so-called where clause. If that condition is true, then value binding is carried out. Here is the idea of value binding in using where. So what we are saying is that if the first element of x is equal to b and its second element is equal to 2, we create two temporary constants, y and z, and set them to be equal to the elements of x. Then we can use those constants within the body of the if statement here and delete them afterwards. And again, we could have an else if condition here and generate y and z like so. If this condition is true, use it within the body of the else if statement here, and at the end delete it. And finally, if none of these two are true, we can just use this arrangement. This is the idea of value binding using where. The way it is actually done is something like this. We have a switch statement where x is the switch parameter. Instead of declaring our constants y and z within the body of an if statement, we bring that out and put it in front of a case like so, followed by the keyword where, and the condition of our where clause is put in front of the keyword where, followed by colon. Similarly for the remaining cases. The very last case, we don't use a where clause because that is meant to act like a default case, and we don't need any conditions for that thing to kick in. So what the first case here means is, first of all, it means that we are declaring two temporary constants called y and z. Secondly, those are initialized by the values of the elements of x. In other words, character A, 1, and that takes place if the condition of our where clause is true. So if this condition is true, then the declaration and assignment I just mentioned will take place, and then those temporary parameters will become available for use within the body of this particular case. If you compare this with the idea of binding, you can see that how they relate. So here we are saying if this is true, then do the declaration and assignment like so, and then use it within the case body. Here we are saying from the beginning that if this condition is true, which is the same as that condition, then declare and assign two parameters called y and z, and assign them to the values of the elements of x, which is what is actually happening here, and then use it within the body of this if statement. In this case, we're using those parameters within the body of this case statement. So they are identical. In the second case, we are doing a similar thing. We are saying that if this condition is true, which is the same as that condition, then declare these two parameters and assign the elements of our switch parameter to these two parameters, which are temporary. They're only valid within the body of this case, and then we can use those within the body of the case as we wish. Finally, because we don't have a where clause here, that means if the first two cases are not successful, then we use this case, which is effectively the default case, and we assign the elements of x directly to y and z, which are declared by this thing, and then use them within the body of this very last case. Value binding can also be used with compound cases. Here's an example. What we're trying to do is trying to assign a value to our temporary parameter y here or here, and if you notice, y here is placed in different positions in these four element tuples. So as a result of this, if this pattern matches our switch parameter, then as long as the last three elements of the tuple are the same as the last three elements of our switch parameter, the first element of our tuple will be used to assign a value to the temporary parameter that we are declaring here. So in this particular case, because the last three elements match, y will become equal to 20, and that 20 is passed on to the body of this case and is printed out like so. Similarly, if our switch parameter had a pattern like this, which matches this, this would mean that, okay, three positions of our tuple match, and what we do is we use the remaining position and assign a value from that position to our temporary parameter that we are declaring within this value. And then that will be used within the body of our case. So in this particular case, because the elements in positions 1, 2, and 4 from the switch parameter match the positions 1, 2, and 4 of the value of our compound case, the second value of our compound case, y will be set to the remaining element, which is 1, and that would be passed on to the body of the case and will be printed out like so. A very important thing here is that because this y is going to be used within the body of the case, it has to however it's generated, whether using this first value or second value, it should have the same type. In other words, it cannot come out from this position with one type and come out from this second position with a different type. So in order to prevent that, Swift will generate a runtime error if these two types are different. So to make sure that those two types are the same, the types of the corresponding position within the switch parameter should be the same. So in this case, where we are seeing an integer type for the first element of the switch parameter and a character type for the third element, these two are not the same, and as a result, this line of code will generate a runtime error. So that is something that we need to prevent. This brings us to the end of the second part of the control flow tutorial.